Hello student, I am Professor Pallavi Shejwal from College of Food Technology, Department of Food Engineering. Today, I will going to discuss on trapezoidal rule. Before trapezoidal rule, we see the concept numerical integration. So what is numerical integration? Evaluation of integral I is equal to integration a to b f of x dx is of common occurrences in mathematics and engineering sciences. Okay, in mathematics or engineering sciences we learn how to find out the integrate, how to integrate a function. So I is equal to integration a to b f of x dx. In many cases, function y is equal to f of x is such that integral I cannot be evaluated analytically. Numerical integration is required to be used in such instances. In many cases, y is equal to f of x. We don't know the function y is equal to f of x. So, integral I cannot be evaluated analytically. In many cases, function y is equal to f of x is such that integral I cannot be evaluated analytically. So, in this case, numerical integration is required. So, in elementary integral calculus, it is seen that I represents the area under the curve y is equal to f of x bounded by the ordinates x is equal to a, x is equal to b and the x-axis. The integral I, we know what is the integration. Integration I represent the area under the curve y is equal to f of x, which is bounded by ordinates x is equal to a, x is equal to b and the x-axis. When the function y is equal to f of x is not known, but the set of points xi, yi, I varies from 0, 1 up to n, lying on the curve y is equal to f of x are given. So area is determined by breaking it into several strips. The determination of area gives the value of integral I. Okay, when many times we don't know the function y is equal to f of x, but the set of points xi and yi, I is equal to 0, 1 to n, lying on the curve y is equal to f of x are given. So for finding the area, we breaking it into the several strips. The determination of area gives the value of integral I. Next, we see the methods to solve numerical integration. There are three methods. We see trapezoidal rule, Simpson 1/3 rule, Simpson's 3/8 rule. So, we see the three rules: trapezoidal rule, Simpson's 1/3 rule, Simpson's 3/8 rule. First, we see what is the trapezoidal rule. Trapezoidal rule, integration x0 to xn y dx is equal to h by 2 y0 plus yn plus 2 into y1 plus y2 plus up to yn minus 1. This is the trapezoidal rule. So what is the trapezoidal rule? Integration x0 to xn y dx is equal to h by 2 y0 plus yn plus 2 times y1 plus y2 plus up to yn minus 1. The above formula can also be written as, see how to remember the formula. Integration x0 to xn y dx is equal to h by 2 sum of the first and last ordinates plus sum of the remaining ordinates. H by 2, y0 is first ordinate, yn is last ordinate. That means sum of the first and last ordinate plus 2 times sum of the remaining ordinates. See how the trapezoidal rule works. It works by dividing the area under the curve into trapeziums and calculating their areas. We divide the area under the curve into the trapeziums by calculating their areas. So area of the trapezium is equal to 1 by 2 a plus b into h. We know the formula to find the trapezium. First we see what is a trapezium. Two sides of trapezium are parallel to each other. So area of trapezium is equal to 1 by 2 a plus b into h. The more trapeziums, the area is divided into, the more accurate the estimate. Suppose we want to find the area under the curve y is equal to f of x between x is equal to x0 and x is equal to xn. We can divide the area into 4 trapeziums of equal width h. See the figure. In this figure, we want to find out the area of shaded region. Okay, area under the curve y is equal to f of x between initial point is x0, last point is xn. We can divide this area into the 4 trapezium of equal width h. The parallel sides of 4 trapezium are given by phi ordinate. See, what are the parallel sides? y0, y1, y2, y3 and y4. So, the approximate area using trapezium rule is integration x0 to xn f of x dx equal to 1 by 2 h into, we know what formula for trapezium, area of trapezium, we use this area with this formula. Okay, so 1 by 2 h into y0 plus y1 plus 1 by 2 h into y1 plus y2 plus 1 by 2 h into y2 plus y3 plus 1 by 2 h into y3 plus y4. We find the area of the 4 trapeziums. Solve this. 1 by 2 can be get common. 1 by 2 and h can be get common. y0 plus y1 plus y1 plus y2 plus y2 plus y3 plus y3 plus y4. So it is h by 2 in bracket. We can also write this y0 plus y4 plus 2 times y1 plus y2 plus y3. So in general, what is the trapezium rule? Trapezoidal rule. Trapezoidal rule is integration x0 to xn y dx is equal to h by 2 y0 plus y1 sum of first and last ordinates plus 2 into sum of remaining ordinates. That means y1 plus y2 up to yn minus 1. So this is a trapezium rule. Trapezoidal rule, sorry. See the notes. It is applicable for equal intervals. So intervals, that means h is constant. The error is of order h square. The error of trapezoidal rule is of order h square. The accuracy can be improved by increasing the number of intervals and decreasing the value of h. If we want to improve the accuracy, it can be increasing the number of intervals and decreasing the value of h. In this, y of x is a linear function of x. In general, trapezoidal rule is less accurate when compared with Simpson's rule. This is the most important statement. In general, trapezoidal rule is less accurate when compared with Simpson's rule. See some example. Take the first example. Use trapezoidal rule to numerically evaluate I is equal to integration 1 to 5 1 plus x square dx by taking h is equal to 1. H is equal to 1 is constant, is equal, x is equal to 1, 2, 3, 4, 5. The difference is 1. Y is equal to, substitute values of x in our function f of x, that is 1 plus x square. So we get the values of y 2, 5, 10, 17, 26. y0, 2 is a y0, 5 is y1, 10 is y2, 17 is y3, 26 is y4. The graph of this function look like this. It is divided into the 4 trapeziums and 5 strips that are parallel to each other, we have to find out the area of this shaded region using the trapezoidal rule. See, by using the trapezoidal rule, integration x0 to xn y dx is equal to h by 2 y0 plus yn plus 2 times y1 plus y2 up to yn minus 1. We have to find out integration 1 to 5 1 plus x square dx is equal to 1 upon 2 y0 plus y4 plus 2 into y1 plus y2 plus y3. Substitute all these values. So, we get 1 upon 2, 2 plus 26 plus 2 into 5 plus 10 plus 17. After solving this 1 upon 2 into 92, we get the answer 46. So, integration 1 to 5 1 plus x square dx is equal to 46. Let's see the second example. In the second example, values of x and log x are given. X is 4.0, 4.2, 4.4, 4.6, 4.8, 5.0, 5.2. Log x is equal to 1.3863, 1.4351, 1.4816, 1.5261, 1.5686, 1.6094, 1.6484. Evaluate integration 4 to 5.2 log x dx by trapezoidal rule. H is equal to, we observe that h is equal to 0.2. Rewrite the table x log x. y0 is 1.3863, y1 is 1.4351, y2 is 1.4816, y3 is 1.5261, y4 is 1.5686, y5 is 1.6094, y6 is 1.6484. Use the trapezoidal rule. Integration 4 to 5.2 log x dx is equal to h by 2 sum of first and last ordinate, that means y0 plus y6 plus 2 times sum of remaining ordinates y1 plus y2 plus y3 plus y4 plus y5. Substitute all these value. H is 0.2 upon 2 in bracket 1.3863 plus 1.6484. I just substituting the values plus 2 times 1.4351 plus 1.4816 plus 1.5261 plus 1.5686 plus 1.6094. Solve this equation, we get 1.8276. So our answer is integration 4 to 5.1 log x dx is equal to 1.82763. Next example, using the trapezoidal rule to evaluate integration 0 to 2 e raised to x square dx taking the 10 intervals. Let y is equal to e raised to x square, h is equal to 0.2 and n is equal to 10. The values of x and y are as follows. We have to split the interval 0 to 2 in, we have to split in 10 intervals. Okay, so values of x, that means h is 0.2. So values of x 0, 0.2, 0.4, 0.6, 0.8, 1.0, 1.2, 1.4, 1.6, 1.8, 2.0. Substitute these values in the function e raised to x square, that we get values of y. y0 is 1, y1 is 1.0408, y2 is 1.1735, y3 is 1.4333, y4 is 1.8964, y5 is 2.1782, y6 is 4.2206, y7 is 7.0993, y8 is 12.9358, y9 is 25.5337, y10 is 54.5981. So by the trapezoidal rule, we have integration 0 to 2 e raised to x square dx is equal to h by 2. Sum of first and last ordinate, that means y0 plus y10 plus 2 times sum of the remaining ordinates, that means 2 times y1 plus y2 plus y3 plus y4 plus y5 plus y6 plus y7 plus y8 plus y9. We know all this value, substitute all this value in our formula. So finally we get the answer, integration 0 to 2 e raised to x square dx is equal to 7.0621. So in this lecture we see what is the trapezoidal rule and how it works, and example based on the trapezoidal rule. Thank you.